Welcome to Miss Nam's Math World. Today we are going to continue for the application of differentiation. First, for the common notation we have already discussed in the last lesson. Please check the answers. Before we continue for the lesson, so please download the decimals, which is called decimal graphing calculator. This one, not the scientific calculator. Okay, the graphing calculator. There is another option which is GeoGebra Classic. GeoGebra Classic, this one. This one is also very useful to check the answers. Alright, so let's go through the detail. So in this session, we talk about tangents to curves. So do you still remember tangents in the circle? So we learned it last year, tangent perpendicular to radius. Do you remember? So this line is a tangent. So you may also get another type of tangent. Alright, so it touches the graph at a point. So this time we also get a tangent to the point, okay, so the curve at the point. It also touches, okay, so the tangent, the most important point is it touches the graph at a point. Alright, and then here we also touch it, and then you may use a ruler to draw it like this. So this graph is the tangent. The first one. At a point means we already got a point which is on the graph. Okay, it must be on the graph or regional function. This one lies on it. Lies on it. So this is a very important concept. Lies on it. If you want to find a tangent, but this time we are not finding with the tangent passes through on the line, but instead it passes through a given point which is not on the graph. Okay, so this time it is not on the graph, somewhere else. So you see this point does not lie on the graph, it's somewhere else. So here the blue one is y is equal to 4x minus 8. So this time it is the tangent to the curve. So let me highlight for you. The blue one, 4x minus 8, is tangent to the graph y is equal to x cubed minus 2x squared. And then passes through means the tangent passes through the point here, which is 1, -4. Okay, so how to do the calculation? And we understand the concept. It means right now we know we want to find a tangent, right? Okay, and then for the format of the tangent, it is actually a kind of straight line. So we may use y is equal to mx plus c. So this is the format, right? Equation of straight line of using the points slope intercept form. So how to find the slope? So we don't find the slope for a curve, right? But instead we can find the slope at a given point, which is we have learned in form 4. So if I want to find the slope at the point here, it's called actually the tangent. Okay, so we want to find the slope of tangent. Slope of tangent, which is the m here, equals to dy dx at the point. So here, you may write down x is equal to -1. Okay, if you are unhappy to write this, you may also write -1 3/e, because this point lies on the graph. Okay, so this is the slope. after that, substitute inside, you may use slope-intercept form, or you may also use y minus y1, y minus x1, slope-intercept, slope-point-slope form equals to m. Right? It's actually nothing special. That means your task is to get the function, differentiate, and then substitute the dy dx, right? The point into the dy dx to get the slope of tangent. Finally, we can find the tangent, equation of tangent, right? By using either method. Okay, find the point on it. I said we already get the point. So we can find the tangent by using both pieces of information, right? Okay, so let's start by working on the first example. So in this question, it says find the equations of tangent to the curve at 1, -6. That means we are going to differentiate the function and then substitute this point in it to find the tangent. So step 1, we differentiate, right? And then we substitute the point in it. 1, -6, that means 3 times 1 squared minus x times 1, -5. So we have completed step 1 and step 2. Step 1, step 2 is done. Step 3, find the tangent, right? So for the tangent, we just write down, therefore, equation of tangent. For the equation of tangent, maybe we don't have the y-intercept, right? So we can't maybe, right? We choose the point-slope form. Just substitute as usual. -1 plus 6, right? The point lies on it. Wonderful. Then we put it in with the slope, right? -5x and then plus 5. So answer, y is equal to -5x minus 1. Or you may answer in the general form. You see, it is not difficult. So let's check the answer by using GeoGebra. So please check the answer. So first, select tangent, and then select the point, select the curve, and the graph will be given. And then here is the answer. And it is exactly the same as the equation of tangent we calculated. So you can see whenever you want to do the counsework, so the technology, right? The GeoGebra is very useful to check the answer. Let's move on to the next video clip for other examples of this session.